you need to make sure your calculator is in radians, and you just type it in to calculate what the answer would be. Another decimal or something. It doesn't give you a pi; it just gives you another decimal. You're trying to write it in rectangular form.
Oh, you did not decimal.
And then you would multiply the R to it if it has an R. If it's not, then it's just that number. All right, in lesson 9, can y'all tell me where you were at with the Z times W? Sign. All right, so this is it's in your journal. Okay. Were you not here yesterday, Braden? So the first 8 questions and half of this 9 is in a video. I made it on YouTube and I put it in Google Classroom. This is all in our journal for notes purpose. There's 12 questions on the test, and I want to go over 12 specific topics. See where I'm trying to go with that. And so we're on topic 9. Yeah. So basically, if you know how to do all the topics we've gone over, then you're going to do just fine. It is on Google Classroom. Yes, sir. You can get the notes from somebody. You can watch the video. I do recommend you watch the video, or at least instead of just copying the answer for somebody, like know how they got the answer, because just having the answer and the work is not going to help you on the test. You got to understand the process and the work. So like you got to know like why did I go from here to here? Because if not, you're going to be looking at the question for 20 minutes and then get stuck again. Again, another recommendation, test taking strategy. Don't spend 20 minutes on a problem. If you don't know how to do it, skip it. Come back to it later. You are able to skip through the test. Once you've gone through the test, you've answered all the ones you know, then go back and start answering the other questions you didn't answer. My other recommendation is there is multiple choice questions. At least answer those. And then go back to your free response and stuff like that. Go ahead. Oh, yeah. Oh, we talked about it yesterday. Let me finish this and we can talk about that. Yeah. I thought you meant like the one before that. I was like, no, I haven't.
One last test question. We only have period to take the test.
Yes. You'll have 54 minutes to complete it. So that's what I'm saying. You need to understand how to do these 12 topics prior to coming to the test tomorrow so that you're able to just get to the work and be good. If you have to ponder, you're going to run out of time. If you're trying to figure out how to do it during the test, you're going to run out of time. Yeah. All right. So to finish this problem off, I then need to find the work here. So to find cosine of 150 and sine of 150, we go to our unit circle. And what is the cosine of 150? Perfect. Plus, what is the sine of 150? 1/2. And there's your I. After this point, you then distribute. So 6 times -3 squared to 2 would give you over 2. So remember, when we multiply, we only multiply the tops of the fraction. So this is going to be -6 square roots of 3 over 2. I do not multiply the denominator. So then what is 6 times 1/2? 6 over 2. Let's simplify this. What can this simplify down to? 3. And then what's this to simplify down to? 3 as well, right? So there is our coordinate. But it told us to find and plot this. Well, you might not know where -√3 is. How can I figure out where this is going to go on a graph? Just type in the calculator and figure out what decimal you get. What's the decimal? Everyone know how to do a square root in the calculator? It's Control X squared if you don't know. Negative even? 196, okay. So then if you're then asked to plot this, that means I need to go 1, 2, 3, 4, 5, and then up 1, 2, 3. So it should be about right there. I will say on the I don't know how accurate the computer program is going to be. But if it counts it wrong, but you were in the ballpark, I'll go back and override it and give you the correct answer. Because I know like a decimal is kind of hard to do. But if the answer is this and you're like in this quadrant, then obviously it's wrong. But if you're like in the ballpark, I'll go back because I can override. Any questions then on that to finish off number 9? All right, let's look at the 10th topic. You got to also be able to find and plot Z divided by W. So to recall, Z was equal to 3 cosine 60 degrees plus I sine of 60 degrees. And then W was 2 cosine of 90 degrees plus I sine of 90 degrees. If it gives it to you in rectangular form, that's great. If it gives it to you in polar form, you just need to turn it into rectangular form. So I'm going to do a little pre-work before I get into this work. What is cosine of 60? 1/2. What is sine of 60? And then I'm just going to then distribute this R. So 3 times 1/2 would just be 3 times square root of 3/2 would be perfect over 2. The denominator does not change. Let me do some pre-work with the W. What is cosine of 90? Cosine of 90? Just 0. And then sine of 90. Distribute out. This is going to be a nice one. 2 times 0. 0, 2 times 1i. So now that I have it in a nice rectangular form, now I can do this math. So Z divided by W would then be 3/2 plus 3 square roots of 3/2 I over 2i. Do I really need that 0? No. We did this on question 1. How do I then divide complex numbers? Good. Multiply the conjugate of the denominator. What is the conjugate of 2i? Negative 2i. Do you remember the conjugate changes the sign of the imaginary number? By chance, had this just been a 2, do I need to do any conjugates? No, I would just have to simplify the fractions. All right, so I'm going to multiply by negative 2i on top and bottom. 2i times negative 2i gives me, multiplying. So this is 2i times negative 2i squared. So I give you negative 4i squared. You multiply the numbers, multiply the i's. On this side over here, I would just have to distribute. So what's negative 2i times 3/2? Good. Again, we just multiplied the numerators. So it's going to be negative 6i over 2. And then negative 2 square roots of negative 2i times 3 square roots of 3 over 2. All right, but 2 i's multiplied together gives you, what is it? Okay, yeah, because it's an I squared, and an I squared does what to the number? Makes it positive. So that becomes a positive. That goes away. And then what's going to happen on the bottom? Also turns into a positive. So then when I come over here to do my work, I'm going to put this in the correct format. So this is, who said, hold on. So I'm going to simplify this. 6 square roots of 3 over 2 will simplify down to what? Just 3 square roots of 3. That's my real number. Negative 6 divided by 2 gives me negative 3i, all still divided by 4. So I had to simplify a little bit on the top before I can do this. Now I got to write this in, so I got to find it and plot it. So to find it, I have to put it in rectangular form. How do I finish this off in rectangular form? Separate the 4, right? So it's going to be 3 square roots of 3/4 minus 3/4 I. That is your answer. And then to plot it, obviously I need to turn these into decimals to know where I'm plotting them at. So what is 3 square roots of 3/4 as a decimal? $1.3. Oh, 1.3, it's fine. Okay, gotcha. Sorry. All right, and then obviously 3/4 is 0.75. Very good. So when I come to a plot, again, if the computer program marks it off, but you're in the ballpark, I'll go back and I'll overwrite it. But 1.3 is between 1 and 2, and negative 0.75 is between 0 and negative 1. So this should be where Z over W is. Questions? Okay. Let's look at the 11th topic. Is everyone done writing? Okay. This one's a pretty good question. I don't think we specifically went over one like this, but the math isn't too bad. It's going to say find and plot Z to the 4th. Okay. So if I take the previous thing that we just did, what did we say Z was equal to in rectangular form? What was the first number? 3 over 2. Oh, just straight up? Okay, then plus 3 square root of 3 over 2. Okay, cool. So that was our Z, so that's where you'll start. And then it says Z to the 4th. Do you recall that Z to the 4th is the same thing as Z squared times Z squared? So it's a little bit easier to determine what Z squared is and then take those results and multiply it again. So it's a little bit of work, but Z squared will just be 3/2 plus 3 square roots of 3 over 2i times itself. How do I multiply binomials? Just full it out. So 3/2 times 3/2. Perfect. 3/2 times 3 square roots of 3 over 2. Very good. So that was that one there. And then 3 square roots of 3 over 2i times 3 over 2. Same thing. And then 3 square roots of 3 over 2 times 3 square roots of 3 over 2. Okay, I'll take that. Ooh, 2 times 2 would be what? 4. When we multiply fractions, we go straight across. So that it has 2 fractions, we go top and then bottom. And then I times I squared. All right, so there's a couple things we can do here. One, what's going to happen to the square root of 3 squared? It's going to cancel out, leaving me just this 3. What's 9 times 3? 27. Good. I got you, though. Yes. Go ahead. That's a good question. That is, because 3 times 3 is what? Good catch. Very good. All right. Now, what's this I square going to do? So it makes this now a negative. So you can always do the steps if you need to organize your information. But now I want to do the reals. Again, you are allowed a calculator. So what is 9/4 minus 27/4? Yep, -18/4. And then what is going to be 9 squared to 3/4 plus 9 squared to 3/4? Good. You're just going to add these numbers here. So it becomes 18 square root of 3/4 I. Go ahead.
I got a question.
So first you do 3 times 3, which gave us 9. And then Caleb told us the square root of 3 times square root of 3 is the square root of 3 squared. And what's going to happen to the square and the square root? Cancel, leaving me with just the 3. So then 9 times 3 gave me 27. No problem. All right. This can be simplified. Well, we have to simplify it, right? Because we have to figure out where it goes. What is -18/4? And then this will be the same thing. Which one? This one or this one? 9. So 9 minus 27. So when you're adding fractions, as long as they have the same denominator, you just work the numerator. So this one, the 4 stays on bottom, but I just go 9 minus 27 is -18. On the top part, you just add the coefficients in front of the square root. So 9 plus 9 is 18. Yes, sir. Here. Okay, so when we are combining like terms with square roots, this is like saying, hey, I have 9 square roots over here and I have 9 square roots over here. So in total, I have 18 square roots of 3 in total. When we multiply though, that is when you have square root of 3 times the square root of 3, which makes the square root of 9. So basically by adding just the coefficients, you're just stating to the reader that I have this many square roots of 3 in total. Or technically square root of 3 is fourths. Now at this point, you need to turn it into a decimal so you can figure out how to graph it. How do I graph this? Huh? Yeah, what's the decimal? I need to know the decimal. Good. That one I can do with you. This one I cannot. Square root of 3's got to be 1.7. So then that times 9, that'd be that'd probably be about 13. No, divided by 2 would be 7.5. 7.79. Sorry, what was the question back there? This is a -4.5 because that's what 9 divided by 2 is. And then you just take your graph. You'll have nice graphs. 4.5 plus 7.79. So again, if you get this wrong because you weren't exactly it, but you're in the ballpark, I will overwrite it. So don't stress about it on that part. So this is going to be between -4 and -5. It's between 7 and 8. So about right there would be. Actually, I apologize. We're only halfway done. Because this is what z squared is. To find z force, I need to do this twice. Yeah, just turn it into decimal. We weren't ready for that part yet. Yeah, that was it. All right, so then you just do the math again. So -9/2 times -9/2. Close. Force, very good. Remember, you want to multiply the tops and the bottoms. Oh, yeah. But with multiplying, you do both the top and the bottom. With adding and subtracting, you just work the top. So then -9/2 times 9 squared is 3/2. Perfect. And then the same thing basically, right? And then just like up here, what is going to be 9 squared to 3 over 2i times 9 squared to 3 over 2i? And then you can clean that up. What's going to happen to the square root in the square? So then 81 times 3. And what's gonna happen with the I squared? Okay. So now what's 81 over 4 minus 243 over 4? It is. If you type in the calculator, it'll simplify your fraction for you too. Negative 162 over 4. Yeah. I'll write that in the next step. And then here again, I'm going to add these guys up. So what's negative 81 plus negative 81? Perfect. And then you could type this in the calculator or simplify it to down to negative 81 fourths. There's a connection here. Minus 81 halves. You're right. Yeah, you just add the numbers in front of the square roots. I feel like there's a pattern here. 3 to the fourths. Three times 3 is 9 times 9 is 81. I wonder if that's just a coinkydink. Yeah. So there you go. So there's your number there. Now give me the decimal version. Thank you. And then when you come to graph, yes, negative 40.5. That's half of 81. I think I'm gonna go by. I'm gonna go by fives. So this will be negative 5. So then negative 10, 15, 20, 25, 30, 35, 40. And then this would be also by fives. So 5, 10, 15, 20. So slightly past that one. So roundabout ballpark. This is where z to the fourth should be. Just an FYI on the test, I don't think it's even fractions. I'm just not really good at coming up with questions. On the test, I think they're all whole numbers. So it won't be as bad. You just make sure you do find z squared first and then go find z fourth. Are you ready for the last one? Yeah, but on the test, I'm pretty sure they're whole numbers. I don't even think they're fractions. I'm just not good at coming up with questions. So that's on me. Maybe I could have just done 2 and 3. On the review, I did. The test, this computer program did, based off what we've learned. What are you telling me? The order? I'm just gonna be honest with you. Like topic 1, like question 1, topic 2 is question 2. So like go in the order of the process. Yes. What was the question? I don't know. She did 81 times square root of 3 divided by 4. No, sorry, 81 square root of 3 divided by 2. Yes. How'd you get 20.25? times the square root of 3. You missed that part. 70? Oh, gosh. $70 what? So that's going to be somewhere right here in this general area. I'm not going to regraph that. It's going to be further down instead of at 20. All right. Ready for the last one? All righty. If y'all thought that one was a doozy, number 12 is the doozy of the question. On 12, it's a lot like number 9, but just gives you the information in a different way. It starts off by saying, hey, I'm not going to say hey. It's going to say the modulus for z is equal to some number. Let's call it 2. So start off with modulus. What does modulus mean? The distance. What's the notation for modulus? The absolute value. All right. So when I give you the modulus, I'm giving you the absolute value, what's the other notation for modulus? What letter does that also represent? It's the R. Very good. So by saying the modulus is this, I'm basically giving you the R. Because remember, to do like 9, you got to know the moduluses and the arguments. Then it's going to follow up with, and W will equal 1 minus the square root of 2i. Come on in. All right, so this is the information it's going to give you. So what you have to do is you need to determine language. Father ears? Yeah, parent ears. It's a parent. Well, also, this is a very small room, so your voices kind of ricochet back off the walls. Yeah, that's good enough. Like if you probably said something like right here, I probably wouldn't hear you. Yes. Yeah, it's all I've put in there so far. Yeah. All right, so again, so it's gonna, instead of giving you like the modulus of each one, this is the information it's gonna get, and it's gonna say find. Does it say find or does it say plot too? It just says find z times w. Ooh. I think it actually says find this. I remember now. Man, I'm sorry. I think it says find. Yeah, it says find the modulus, which is the distance of z and w. But that's just simply just going to be the modulus. Yes, sir. Go ahead. And then be done with it. I don't think that's. No, I think that's what it is. I think it says like find the. I think it's like, oh, man, I had this down yesterday. I think it's like find the distance between Z times W. Next, I'm in the middle of a recording. I think it's, yeah, it's Z and W and Z. So what we have to do is we have to go find, no, we have to find the coordinate of ZW, find a coordinate for Z, and then plug it into the distance formula. That's it. So it's a little bit of like nine. All right. So this is the information given to you. It says like the modulus of Z is equal to something. And here's a complex number. I have to find out what Z times W is, just like number 9 is. And then I have to do an extra step by finding the distance between ZW and Z. Good. Okay. So when it tells you the modulus, the best thing to do is kind of figure out what coordinate you can get that would give you like a solid number of 2. So there's multiple ways to like find different coordinates and multiple answers that would still give you the same conclusion. But if your modulus is 2, so like if this is it right here, a great coordinate would be multiple things. You could say 2 plus 0i or 0 plus 2i. Either way works. We did this in example. Is it lesson 7? 6? Somewhere around that part where like you had to tell me like, can a whole number, a real number be written as a complex number type thing? And that's where this concept's coming in. I don't know what's easier for you. I'm going to go with 2 plus 0i. If you want to go 0 plus 2i, you're correct there as well. And remember, modulus is distance. So if you're unsure if this is correct, a correct answer, what's the square root of 2 squared plus 0 squared? And what's square root 4? 2. So you came up with a great example. All right, this is what we'll use to find the distance. We just got to figure out Z times W. So to find out Z times W is I have to calculate the R, just like in number 9. So I need to find out what the modulus is of W. Remember, that's just going to be 1 squared plus negative 2 squared. What's 1 squared? 1. What's the square root of 2 squared? 2. It gives you the square root of 4, which is just back to 2. 1 plus 2 gives you 3. So that's the square root of 3. So now I could calculate Z times W, which would just be 2 times the square root of 3, which is just 2 square roots of 3 because you can't really do anything with it. Recall that Z times W is the same thing as, hold on, let me rewrite this as a formula for you. Z times W is the same thing as Z times the modulus of W. The square root of 2 squared is the same thing as square root of 2 times square root of 2, which is the square root of 4. Square root of 4, though, is 2. So you get 1 plus 2, which is 3. Square root of 3. What is your question? It's negative square root of 2. Because yeah, that's the same question that Jacob just asked. So that's why we got 1 plus 2 and got the 3. Now you're good. You're good. And then I can just multiply 2, and there's my modulus. The issue is now is I have to figure out what the argument is. The argument of 2 plus 0, how do I find the argument of Z? Zero over 2, good. And then type that in the calculator. Tell me what you get. The 0 divided by 2 is 0. What's the tan inverse of 0? That's a 2. It's B divided by A. Does this say 0 degrees? What? All right, so I do get 0 degrees. And then ask yourself, does that make sense? Where does 0 or 2 comma 0 fall? Huh? It actually falls on the x-axis at 0 degrees. It doesn't fall in a quadrant. It falls exactly where it's lined up at. So that does make sense, and I don't have to do anything to it because it gives me the correct answer. After that point, I need to find out the argument of W, which is going to be tan inverse of perfect. Whatever that gives me. Add what to it? Because what quadrant does it fall in? The negative square root of 2 over 1. So it is. Positive comma and negative. So a positive comma and negative falls right there in quadrant 4. Yeah, you don't have to really care exactly where it falls. It just needs to know it falls into that category. What is this equal to? 2.4? Is it 79 or 76? And then the 3. 7.3. I don't know what the decimal is. Seven four. Yeah, and so this would be a 6. I think it on the test. I think it says like round to the nearest whole number or something, but 26. That was the only thing I was spot off. All right, so now that we have this, no, it won't. So now to find the argument of Z times W, I just add the argument of Z plus the argument of W. So this would be 0 plus 305.26, which happens to be. We did this part next. Because that's what 0 plus this is. This is itself. Now I can go find the complex number of Z times W. So I can find the distance. So Z times W is going to equal R, which is 2 square root of 3 times cosine 305.26 plus I times sine of 305.26. Obviously, this is not on our unit circle. So make sure your calculator is in degrees and then go tell me what the answer is. To save yourself some time, you could technically go ahead and just do all of this, like 2 square root of 3 times cosine of 305.26, get the decimal, and then do 2 square root of 3 times sine of 305.26, get the decimal, and then you'd be good to go. So what's the decimals? I don't know. This is going to be a positive. This is going to be a minus. What is it? 1.9999. I just went to 2 because 1.9999 is goes nothing. Oh, okay. So in the calculator, type in 2 square root of 3 times cosine of 305.26 in degree mode. Make sure you're in degree and not radian. And then you would do 2 square root of 3 times sine of 305.26 to get the second number. Okay, so that's if you don't have a degree symbol. This right here, when we found it, technically was a degree. So it's not that if you don't have if you have a decimal, it's radian. It's that if it doesn't have the degree sign. No, just type in sine and then just write the I out, and when you write out your final answer. All right, now the last step. Yeah, 1 second. Huh? What'd you get? Are you in degree? So you did 2 square root of 3 times cosine of 305.26. Okay. It won't let me read. Oh yeah, one side at a time. Sorry, one. No, you don't add it together. You write it like this because one's going to be a non-I, the other one's going to be an I. All right, so again, the final thing to find the distance between these two guys. All you got to do, wherever I'm at, is take the differences of your A's. So you get 2 minus 2 squared plus take the difference of your I's. So 0 minus negative 2.83 squared. So this ends up being 2 minus 2 is squared would be. So that's just going to go away. 2 negatives make a positive. So this is really 2.83 squared. What's going to happen to square and the square root? So 2.83 will be your answer. Happens. I remember doing a problem in advanced vector calculus. So I think this was called. And I think I spent 5 pages front and back to get the answer of 1. Yes, because I got the answer of 1 and I spent like a week trying to figure it out. And it was 5 pages front and back. Because that's my class. I had to do it. It was a problem I had to do. Yeah. Everyone got this written down? Okay. Now that professor